Hi, everyone. I'm Crista Cowan. I'm the corporate genealogist here at Ancestry. And that means that I am primarily responsible for family history education, both inside the company with employees and outside of the company with you, our customers. And today we're going to be talking about AncestryDNA 101. So what I would love to know from you is whether or not you have taken an AncestryDNA test. And so I'm just going to pop a quick, well, maybe I'm not going to pop a quick poll up on the screen. I thought I was. If you could just answer in the chat whether or not you've taken an AncestryDNA test. Looks like most of you have, a few of you have not. Okay, fabulous. That is good to know. Okay, so AncestryDNA is a saliva sample test. So if most of you have taken it, I won't go too much into the details, but basically you provide a saliva sample, it's sent off to the lab, it takes about 6 to 8 weeks to get your DNA results back from the lab. Those results are delivered to an Ancestry account. So every one of you, the few of you who haven't yet taken it, should, when you submit your sample, activate your kit. There's instructions to do that with an email address owned by you. And that then becomes how you log into Ancestry in order to access those DNA results. So here's what we're going to do today. I'm going to walk you through just some basics about what we call DNA inheritance. It's a really foundational principle that everyone needs to understand in order to make sense of their DNA results. So we're going to talk about DNA inheritance. Then I'm going to walk you through what you get with your results, including AncestryDNA origins, which is the different regions of the world where your DNA comes from and how to read that. We'll talk a little bit about SideView technology, which helps you determine which side of your family tree some of that information came from. And then we'll take a look at the AncestryDNA match list. So those are the things that we're going to cover today. Again, this is an AncestryDNA 101 class. We'll dive deeper into the match list and some other things with that, with some other classes that we do. Okay, so let me share my screen. I'm always just a little hesitant. I want to make sure this works perfectly. Beautiful, great. Okay, so there are 20, every person has 23 pairs of chromosomes. So that's what makes up your DNA. You get in that pair, one of that pair from your dad and one of that pair from your mom. So every person has 23 pairs of chromosomes, and you get half from dad, half from mom. However, it is a random 50% of your parents' DNA. And so I'm just going to walk through a quick little example of exactly what that means to help you start to wrap your brain around that, because like I said, it's kind of a foundational principle. We're going to do a little biology class today. And science was not my strong suit, so this is why we created this page, was to help people understand this concept whose brains don't work in science. Okay, so we are going to take a look at an analogy or an example of exactly what it means when you get a random 50% of your dad's DNA and a random 50% of your mom's DNA. And the way that we're going to look at this is we're going to use some just letters of the alphabet that make up some names as a metaphor for this little family that we're going to take a look at. So let's imagine someone, and their name is Andrew. Andrew very conveniently has 6 letters in his name, because then we can divide it in half, okay? Now, when Andrew and his wife, Sandra, have a child, they are each going to pass on 50% of their DNA to their child. That DNA is going to get recombined, and that child's name is going to be Edward, okay? You with me? You see how that's happening? So when we say that you get 50% of your dad's DNA and 50% of your mom's DNA, this is what we mean. You get a random 50% of their DNA. You do not get an equal 50-50 split of all of their DNA. So you're not getting half of an A and half of an N and half of a D. Like, that's not how it's being divided. It's a random 50% of their DNA that gets passed on to you as their child. Okay, now let's imagine that there is another couple, Graham and Elaine, same thing. A random 50% of their DNA, it's going to be recombined, and you're going to have a child named Angela. Still with me? Okay, now we're going to take that a step further. We're going to say that Edward and Angela now have a child. Actually, they're going to have 3 children. And those 3 children are each going to get a random 50% of mom and dad's DNA. And those 3 children are going to come out looking a little different. This is important. So the first lesson is you get a random 50% of dad's DNA, a random 50% of mom's DNA. The second lesson is every child gets a random 50%. The reason that's important is because unless you are an identical twin, you and your siblings do not have the same DNA because you each got a random 50% from mom and dad. Now we can tell that there's some similarities, right? All 3 of these children have a G from mom. They look alike. A couple of these children have an R from dad. All 3 of them have an A from dad. A couple of them have an N from mom. Do you see? So they have things in common because they are siblings, but they do not have identical DNA because they are not identical twins. They are just full siblings in this case. Now, when you look at all 3 generations here in a single chart, there's some things that you start to notice. We can track back through the generations where that DNA came from, right? The G came from maternal grandpa, passed on to daughter, passed on to grandchildren. All 3 of them got it. That A came from paternal grandma, passed down. All 3 of them got it. But then there's also some things that get lost in the process. So for example, Andrew had an N that didn't get passed down because Edward only got half of his father's DNA. Andrew had a W that did get passed down to Edward, but then Edward didn't pass it down to his children. So that piece of DNA got lost in this branch of the family tree. So as you start to think about, you can start to connect the dots between what that means for your DNA results. This is a really foundational thing to understand. There are pieces of DNA that in a branch of a family tree get lost because you only got half of your parents' DNA, which means there is half of their DNA that you did not get. Now, it's totally possible that Andrew had another child. That other child got the W. That child passed the W on to one of his children. So in other branches of the family tree, we can start to see pieces of that DNA that did get passed down and did survive. There's an interesting mathematical formula. So in addition to science, you're going to have to do a little math with DNA. The interesting mathematical formula is this. One child gets 50% of their parents' DNA. The next child gets 50% of their parents' DNA, but because it's random, it's half again, which means between these 2 children, they have 75% of their parents' DNA represented. And then you add a third child and it's half again. And now they have about 87% of their parents' DNA represented. And then another child and it's half again. And now they have about 93% of their parents' DNA represented. And another child, right? Do you see, like the more children you have in a family, the more likely it is that 100% of that parent's DNA was passed down to the next generation. Now, some of you are already ahead of me, okay? What does that mean? That means that if Andrew and Sandra and Graham and Elaine are all deceased, the more of their children you can test, the more of their DNA will be represented and available for you to make family history connections. The more you're going to get a complete picture of the DNA of Andrew and Sandra and Graham and Elaine because you're using their children's DNA to represent them, okay? So anytime you have a complete generation who is deceased, or even parts of a generation who are deceased, you want to test everybody in the next generation to make sure you have as much DNA represented as possible. Here's the other thing that it means. If Edward and Angela are both alive and both willing to take an AncestryDNA test, technically you don't need to test any of their children because 100% of their DNA is represented by Edward and Angela. But if one of them is deceased, then you want to test as many children as possible, okay? You also might just want to test their children because it's interesting to see who inherited what. And you'll see when we get to the match list that that's exactly what I've done with my own family. So whenever generations are missing, you want to test as many people as possible in the next generation. And you don't have to test another generation down if you've been able to test both parents, unless you're curious about what random 50% each child tested. Okay, so here is what I want to know. Like, as you think about that concept of random inheritance, what questions does that naturally bring up for you? Okay, what do you naturally want to start to think about, or what questions does that raise? Enter those questions in the chat. Okay, the Q&A is specifically for if you have a question or need a link, or that's what we're using the Q&A for. Member Services is looking at that. I'm not, but I am looking at the chat. So, okay, Christine wants to know if there's 8 children, how much DNA gets passed on. So it's just a math problem. Okay, you take 50% and you divide it by 2, that's 25, and then you add it. So 2 children will have 75% of their DNA, their parents' DNA. Then you take 50% of 25 and you add it. So now 3 children will have 87.5% of their parents' DNA. And then you take that 12.5% and you divide it in half and you add it. So you just do that, divide it in half and add it with every new child, and that will tell you how much of the parent's DNA is represented. Now, because you keep dividing it in half, technically you never get to an absolute 100%. So for those of you who are math brains, you'll understand this. But, let's get that, there we go. But it's important to know that when you have about 5 children, you're kind of at about 100% with some rounding errors and because of the random inheritance of DNA. Bonnie wants to know, does the sex of the children make a difference in the DNA? And the answer is no. Every child, male or female, gets 50% of dad's DNA and 50% of mom's DNA. And so you can see exactly what that means, right? 50% of dad's DNA, 50% of mom's DNA. Now, what that means is, because it's a random 50%, you only get about 25% of each of your grandparents' DNA, but that's also going to be random. So think about this for a minute, right? If I have I get 50% from dad, 50% from mom, but dad gave me a random 50%, which means technically he could have given me, 21% from grandpa and 29% from grandma. The key is just that the DNA has to equal the 50%. And grandpa could have only given, a certain percentage of one of his parents and another percentage of the other to his child that was available to pass on. So there's some basic math that you can do that just means kind of generally you get half every time you go up, but it's not always going to be equal. The only time it's equal is when you're looking at the DNA you inherited from each parent. So somebody asked about how much DNA would I have from a 4 times great-grandparent? Well, you don't know really until you start looking at your DNA matches, and we will get to that. Okay, so let's take a look at what you get with your DNA results. I mentioned that you spit in a tube, you activate your kit online at Ancestry.com using your own email address. Then you send the kit off to the lab. They do their thing. It takes 6 to 8 weeks. Those results then are returned to your AncestryDNA account, and you log in using that same email address you used to activate your kit. I'm going to share my own DNA results. I'm completely comfortable doing that. And I do have the permission of my highest matches on my match list to do that. So we are going to take a look at exactly what you get in your DNA results summary. So this is your, DNA homepage, essentially. You can see my name is right here at the top. That's because we're looking at my test results. We do have the ability on Ancestry to share test results with each other. So I have test results shared from my parents and my siblings and my grandma and my aunts and uncles and some cousins, right? Like lots of people have shared their results with me. All I have to do is click on my name and it will give me a drop-down list and I can switch to view any of those tests, okay? You can invite people to your DNA results over here on the top right with this invite button. That's going to allow you to share those results and to compare them with each other if you so wish, okay? Now, I am on the DNA homepage or the summary page, and we're going to take a look first at the ancestral regions. This is the piece that most people think of when they think of an Ancestry DNA test. What they're thinking of is, oh, I'm going to get percentages of where in the world my DNA is from. Couple of things to remember. First, random 50% from each parent, which means there's 50% of their DNA you didn't get. So keep that in mind. The second thing you need to remember while you're reviewing your ancestral regions is that this is a modeled population looking at where in the world your DNA was 500 to 1,000 years ago. Now, I want you to think about your family tree. Parents, grandparents, great-grandparents, great-great-grandparents, right? By the time I get to my 3 times great-grandparents, I'm in about the late 1700s, early 1800s. It's only 220-something years ago, okay? We're looking at where your DNA was 500 to 1,000 years ago with these ancestral regions. So for some of you, you may have had very, very deep roots on all branches of your family tree from a single place in the world. Some of you may have 100% Irish or 100% Ashkenazi Jewish or whatever, right? Most of us are going to be a mix of things because people were very mobile for centuries, right? It's not just modern transportation that has made that mobility possible. And so we are going to look at where that DNA came from. It also means that lots of us have like I have a great-grandmother whose parents were both born in what is now Poland. It was part of Prussia at the time. They were German-speaking. I have another great-grandmother whose parents were both from England, and her other grandfather was from Germany, another who's from Scotland, right? Like so, but where were their ancestors from 200, 300, 400 years before that? You don't know. Because most of us don't have family trees that go back this far. So kind of keep that in the back of your mind as you look at your ancestral regions. The other thing to know is that Ancestry updates the ancestral regions about once a year, typically in the fall. Now, that's not a given that that's always going to happen or always going to happen on that timing, but that's been historically what has happened. So as the reference population grows, that panel of people that we're comparing your DNA against in order to make these this ethnicity estimate show up, that is going to adjust. You're never going to probably switch from being continentally European to being continentally Asian or African. What you are going to see is shifts, usually within neighboring regions, as we get more refined and as the reference panel grows. So keep that in mind when you see the update come through. And if you're somebody who hasn't looked at your AncestryDNA origins in the last year or two, it's worth taking a look. Because the other thing we start to do is as that reference population grows, we can start to split out regions and get more refined. So you'll see here my ethnicity breakdown. My ancestral regions come from England and Northwest Europe, and Ireland and Scotland and Germanic Europe and Wales and the Baltics. So that is kind of how my DNA breaks down, looking at that estimate 500 to 1,000 years ago. One of the things I would encourage you to do is click through to view these different regions and read about them. Ancestry has worked with, we have a staff of population geneticists. We work with historians and others who help us write these articles and really understand why the DNA from this part of the world looks like this. And we provide these articles that give you detailed information. One of the things I want you to pay particular attention to is this right here. If you come back with DNA saying your DNA is from England and Northwest Europe, it's important to understand that people with DNA that looks like that also can be found in other countries, because DNA is not about countries or nationality. It's about ethnic origins based on your DNA. So it's about connection to populations of people, and those populations of people could live anywhere. So as you start to think about, oh, well, my great-grandfather was Swiss, why am I getting English? Well, people who have DNA that looks like this also can be found in Switzerland. And that's what you're going to see that on every one of these informational pages about those regions. And so just scroll down, lots of really great information on these pages. I encourage you to click through and read those. Plus, it's just kind of interesting. Okay, so that's your regions. Again, that's looking at where in the world your DNA was 500 to 1,000 years ago. The next part of your DNA origins results you're going to get is what's called journeys. So Ancestry has more than 25 million people who've taken the AncestryDNA test. It's the largest consumer genomic network in the world. And what that means is because we have so much data to work with, we've started to notice these patterns of clusters of people who match each other. And those clusters become really interesting when you start looking at the data, because in addition to having 25 million people who've taken an AncestryDNA test, Ancestry also has another 130 million family trees on our site. So we can take that cluster of people who all match each other for DNA, and we can start to look into other data to see what do these people all have in common. And we can start to figure out that what they all have in common is usually a place where they all lived within the last 300 years, usually 100 to 200 years ago, but for sure within the last 300 years. And Ancestry has been able to identify thousands of these clusters of DNA matches, and we have been able to then label them as journeys that your ancestors took within the last 300 years. So if you have something that comes up in a journey, this is a population of people that you are connected to. Now, it may be because somebody immigrated somewhere 200 or 300 years ago and had a bajillion descendants. That's a legit word. And your family may never have left, but part of the family took that journey. And so you have a lot of DNA matches that connect you to that place. So that's another way that these journeys show up. So I'm just going to show you mine and just talk through those. But I hope that what you're doing is on your phone or your tablet or another computer screen while you're listening in, you're walking through your own results and diving into them a little bit. So the first journey that I have here is what's called early Upper South settlers. And it covers a really wide swath of place, right? It starts here in Tennessee, goes all the way across the state, ends up in Northwest Arkansas. Now, if I knew nothing about my family history, the fact that I now have a clue that I am connected to this specific place within the last 300 years is really exciting to me. The fact that I do know a lot about my family history and that I know that this is the exact migration path that my family took somehow is even more exciting to me, because it means the DNA is proving what I already know about my family history. So my mom's family lived in East Tennessee. She had an ancestor, she had several ancestors who migrated into that area when the Cumberland Gap opened. They got land grants from Revolutionary War Service, settled there. And then starting in 1831, over the course of about 20 years, there was a series of migrations from this part of Tennessee all the way across to the northwest corner of Arkansas, where both of my grandparents on my mom's side were born. My grandma was born in Benton County, Arkansas. My grandfather was born in Washington County, Arkansas. And we still have cousins and until just recently, a last surviving aunt of my mom that lived there. So that is really exciting to me to know that the DNA is showing absolutely that I am connected to this particular place. My other journey is what we call, let's zoom back in here, and click on that, is a Utah settler's journey. Now, my dad's mother was born in Twin Falls, Idaho, but both of her parents were born right here in Utah County, where I happen to be sitting at the moment. Her father was born in Lehi, which is where the Ancestry offices are. Her mother was born in Pleasant Grove, which is where I live. So again, super exciting to see that I have DNA matches that connect me to this place. Now, here's what you don't see in my journeys. Nothing from my dad's dad. I do not have either enough matches or I did not get enough of his DNA in order to connect me to a community from his side of the family tree. Remember, this is both of my mom's parents are from this place, and my dad's mom's family is from here. But my dad's family, not represented in my journeys. Again, that could be because not enough people have DNA tested to connect me, or because I did not inherit enough DNA from his side of the family tree. So, who am I going to test? I'm going to test my dad. I'm going to test my dad's siblings. I'm going to test other people to see, excuse me. I'm going to test other people to see if they can connect to that particular branch of our family tree, and if we are popped into a journey because of that. That random inheritance piece really messes up our brains sometimes when we start to think about this. Okay, if you have questions specifically about that, you can put them in the Q&A or you can pop them into the chat. Like I said, our member services team is in the Q&A answering those questions. Typically, they're going to provide links to resources that are available. And then I'm keeping an eye on the chat and will answer those questions as I can. Now, this next piece, so all of this is what we call origins, your regions that connect you to where your DNA was in the world 500 to 1,000 years ago, your journeys that connect you to places you have family where they have lived within the last 300 years. And then for those of you who have an Ancestry subscription, and you're going to have access to some additional information. So you just get the journeys and the regions for free if you've taken a DNA test. But if you want to see some more granular detail, you have to have any level of Ancestry subscription. And that is what's called by parent. So by parent is done with what's called SideView technology. Our scientists have been able to create a proprietary system that looks at your DNA compared to all of your DNA matches, and we can start to break out which side of your family tree that particular piece of information came from. Remember, I said every one of us has 23 pairs of chromosomes, one in a pair you got from dad, one in the pair you got from mom. Now, here's the problem. Your DNA doesn't come labeled in your body, mom's side, dad's side. So all we can do is we can tell you, parent one or parent two. We can tell you which, like we can split out that you got this kind of DNA, this region or this journey from this parent and this journey from another parent, but we don't know which one is mom and which one is dad. And it can be like parent one could be mom for me and parent one could be dad for you. So it's not always the same, okay? Because again, it doesn't come labeled in your body. So when you look at your origins by parent, some of you are going to be able to tell very clearly, very immediately, exactly which parent is which. Some of us, it's a little trickier. So for example, if I look at my ancestral regions by parent, I probably would have never been able to tell because my parents are very similar genetically, right? Lots of European, a little bit of Irish from both, some Scottish in both, right? Like so it would have been difficult to tell them apart. However, that journey very clearly mom's side, dad's side. I know that my dad's family is connected to Utah and my mom's family is connected to Tennessee and Arkansas. And so because of the journeys, I was able to label parent one as mom and parent two as dad. And I was able to make that distinction. You can edit those parent one, parent two labels to read correctly maternal or paternal based on what you know about them. Now, some of you still won't be able to tell. Some of you have parents, again, who are not only very genetically similar, but also may come from the same regions of the world. Their families may have, intermarried for centuries, right? Like you may come from Puerto Rico, or you may come from Hawaii, or you may come from Louisiana, and both parents come from that same population of people. Even if they're not related to each other, they still come from that same population, and it makes it a little trickier to tell. And so in that case, you're going to want to go to your match list. So the match list is the next piece of results that you get with your AncestryDNA test. We take your DNA and we compare it to the other 25 million people who've taken the AncestryDNA test, and we put them all on a list to show you who you're related to, how much DNA you share with one another, and based on their self-reported age and gender and that amount of shared DNA, we can predict a possible relationship for you to that person. Now, let's go back to our foundation. Remember, inheritance of DNA is random. So the only relationship that we can typically be almost 100% sure of is parent-child. Beyond that, it starts to get a little bit fuzzier because there's a range of relationships available based on that amount of shared DNA. So we'll give you some predicted relationships, but those relationships are going to be just predictions. You're going to have to do a little bit of research to figure it out. Or you're going to have to test additional people in your family so that you have a point of reference to compare against. Now, in my case, I mentioned I've tested both of my parents. So Stephen is my father, Sue is my mother. I share 50% of my DNA with each of them exactly as expected. It's predicted that he's my father and she's my mother, and that's fantastic, right? That is exactly as it should be. This is one of the places where people start to make surprising discoveries with DNA. And so just be aware that it is possible to make discoveries that might be a little bit uncomfortable or awkward in the process of reviewing your AncestryDNA match list. Next up, I mentioned that I've tested all 4 of my siblings. So I'm the oldest of 5 children. I have 4 younger siblings. These 2, Angela and Jeffrey, are actually twins, obviously not identical twins. And so they're going to share the same amount of DNA with each other as any other 2 siblings. So we have 5 siblings in our family, and you'll notice that I share a range of DNA with each of them. I share the most amount of DNA with my baby brother here, and then it kind of works its way down from there. But you'll notice between Adam and Jeff, I share 2,700 centimorgans of DNA with Adam, 2,500 centimorgans of DNA with Jeff. Like the fact that there's that little bit of a swing is that random inheritance. We each got a random 50% from mom and a random 50% from dad, and it doesn't always equal out to exactly 50% between siblings. But we can still tell that they are full siblings because of the range of DNA that they share, and just some additional information on the back. And so we will predict this relationship as full siblings. Now, the next category of DNA is going to be the group of people with whom I share about 25% of my DNA. And one of the things I want you to start thinking about is relationships in terms of ladders. Okay, here's what I mean. And I'm actually going to stop sharing my screen for just a second because I want you to see my whole face and my hands especially. Okay, so if you and your brother, okay, share about 50% of your DNA, and then you have a child, that child will share about 50% of their DNA with you, but how much DNA are they going to share with their uncle? Okay, so I want you to think about that for just a minute. Half, these two people share about half, this person shares half with this person. So these two people are going to share about 25% of their DNA. Now, let's say the uncle has a child. These two people then are first cousins to each other because their dads are brothers, okay? So half again. So these two people are going to share about, yep, I see it, Deb and Brenda have got it, about 12.5% of their DNA. Now this person has a child, half again. So these two people now are first cousins, one time removed, and they're going to share about 6.25% of their DNA. And then this person has a child. These two people are second cousins because their parents are first cousins and their grandparents are brothers, right? These two people are going to share about 3% of their DNA. So think in terms of relationships as ladders, and every time you go down on either side, the DNA gets cut in half, and it gets cut in half, then it gets cut in half, and it gets cut in half. Okay, so that is what we're looking at. And that centimorgan amount is just a measurement for how much DNA these two people share. But you'll notice that we also give you the percentage. So we show you the amount of shared DNA and then the percentage of shared DNA. But because DNA inheritance is random, it's not always going to be exactly 25% or exactly 12.5% or exactly 6.25%. Okay, so we will give you a prediction. In this case, Brad is my uncle. It's my dad's brother. He and I share 1,946 centimorgans of DNA. That's about 28% of our DNA. That's great. Okay, Rhonda is my dad's sister. She and I share about 27% of our DNA. Lenore is my mom's sister. We share about 24% of our DNA. Doris is my grandmother, my dad's mom, and we share only about 21% of our DNA. Now, my grandfather died before DNA testing was a thing, and so we haven't been able to test my grandfather. But knowing that I share 21% of my grandma's DNA means that I probably have about 29% of my grandpa's DNA, because together they have to equal 50%, because that's what I inherited from my dad. Okay, do you see what's happening? It's math and science, but it's math and science that I think is doable for all of us if we just practice it. I am neither a math nor a science person. And when I started working with AncestryDNA back in 2012, when I took the test and then started testing my family, it was so over my head, it felt like a foreign language. But I promise you, just like learning a foreign language, that the best and easiest way is immersion. Just dive into it and start to think about it. 50%, 50%. Think about that ladder. And then the numbers will start to make sense. It'll be like a switch flips in your brain at some point. but just stick with it. I know you can do it, okay? Now, another thing that we've done to help you is, in addition to providing you with a predicted relationship, you can click on any of these predicted relationships, and we will give you a little chart that explains what's called the frequency of relationships, okay? Now, I don't want to lose you here, but I do want you to start to think about this. We'll tell you what we think the relationship is, but you know your family better than we do. And there are lots of variables involved. Random inheritance of DNA is just one of them. So we will show you what all the possible relationships are at that amount of shared DNA, and what the frequency is that it is going to be one of those relationships. So in this case, I share 21% of my DNA with Doris, and Ancestry has predicted she is my grandmother based on her age and my age. But she could be my aunt, because an aunt and a grandmother share the same amount of DNA. An aunt and a niece and a grandmother and a granddaughter share the same amount of DNA. She could also be my half-sister if she wasn't 50 years older than me. I mean, biologically, though, do you see? She could technically be my half-sister. So there's some other variables at play where I know she's not, but that is possible genetically based on how much DNA we share. She could also be my niece or my granddaughter. Again, because of our ages, neither of those relationships are possible, but we're going to show you, just based on the DNA, what the possible relationships are. Now, it's an 88% frequency that 21% of shared DNA is this kind of a relationship, but there are outliers that say it could be one of these other relationships. And so we just always provide you with that chart that you can come in and take a look and see what are the other possible relationships based on this amount of shared DNA, okay? So again, don't get overwhelmed with the math and the science and the numbers of it. Just kind of immerse yourself in it and kind of let it kind of flow over you, flow through you, and just start to get familiar with the tools that are available to you. Because if you know all of these people at the top of your AncestryDNA match list, this is going to be a little bit easier for you. But if you don't know those people, it gets a little trickier. You have to figure out exactly how to read those charts and understand what the data is telling you. If you, for example, are using your AncestryDNA test because you're looking for a biological parent or grandparent, there are going to be people at the top of this list that you likely do not know. And so it's important for you to understand what the possibility of those relationships are. If you took an AncestryDNA test and there are people at the top of the list that you do not know, but you think you know who both of your parents are, you want to review this critically and make sure that you understand what you're looking at. If, for example, you tested a sibling, you thought they were a full sibling, and you share only 12-ish% of your DNA, 25-ish% of your DNA, that indicates that they might be a half sibling instead of a full sibling. And that might be new information to you. So this is the place where you start to kind of understand your genetic relationships to the people in your family tree. Okay, let me do this. I'm just going to stop sharing for a second so that I can pop over here to my Q&A doc, just checking to see if there's anything else that we need to answer before we dive into the last little bit of your DNA results here. It doesn't look like there's anything immediate. Oh, okay, awesome. Thank you, Michelle. So here's what I want you to do. I'm going to give you homework, okay? So many of you have taken the AncestryDNA test, but my next question to you is this. Have you attached your family tree to your DNA test? So in the chat, again, not the Q&A, in the chat, what I'd like to know is, have you attached a family tree to your DNA test? I'm seeing lots of yeses, a few no's. Okay, good. That's helpful. Lots of yeses, a few no's, a couple not yets. Okay. If you have not yet started a family tree on Ancestry. Thank you, thank you, thank you. Awesome. Okay, some of you don't know. Good, I will show you. So we're going to wrap up with that. I'm going to show you how to make sure you've got the tree attached. And then for those of you who have a tree attached, I'm going to show you just a couple of the filters that are available to you. So that's what we're going to do with our last 10 or 12 minutes together. And then I have one more little thing for you. So here's here's what I want you to do. On Ancestry, when you are viewing your DNA match list, the easiest way to see if you have a tree attached to your results already, okay, is to look right here at the top of your match list. You see how mine says continue building the Cowan working tree to find common ancestors. That's because I have the Cowan working tree attached to my DNA results. If you're not sure, you're going to come up here to your account settings. Okay, so account settings. And in your account settings, you're going to go look for the DNA section. Let me just turn my screen off again, because if I pull up account settings right now, you're going to see all of my account settings. And then I just want to take you to the place that you need to be looking at. Okay, DNA. There we go. Okay, resharing my screen. Okay, and who is it here? Somebody just asked, Kendra just asked, the benefit of attaching DNA to your tree. I will tell you the answer to that in just a minute. Okay, so when you go into your account settings and you click on the DNA section, this is what you're going to see. Your test is going to be right here at the top. Any tests that have been shared with you are going to be down here at the bottom. I'm going to click on my own name, and right here under DNA and family tree linking, this is where you're going to see exactly who that test is linked to. Now, this is really important. You want to make sure that the test is linked to the person in the tree who took the test. So if you took the test, this is your test results, you need to be in your tree. I know some of you have trees that you've started with, like you started it with your mom or your grandpa, and you've got multiple trees. Your DNA can only be linked to one tree, and it needs to be linked to the person in the tree who took the test. That's super important, okay? And Kendra, here's why it's important. It's important to link your DNA test to your tree, because then Ancestry can use all of our automated processes to try to connect you and your DNA matches with a common ancestor. So that's what we're looking for. You're going to get a DNA match list whether you have a tree or not. You're going to be able to go through your DNA match list and look at those matches and see how much DNA you share with that person, whether you have a family tree or not. But if you want the Ancestry algorithms to do some of the work for you in trying to find a possible common ancestor between you and that match, you need to have a tree linked. If you want your DNA matches to help you figure out how you're related, it's helpful to have a tree linked. So let me just show you an example of what one of those looks like. If I come in here and I click on this filter, because I have a tree attached, and because so many of my matches have trees attached, I can click on this common ancestor filter, and that will then filter my DNA match list to just those people where Ancestry thinks they know who the common ancestor is. In the case of my siblings, it's my parents. In the case of my aunt and uncle, it's my grandparents. In the case of my grandma, it's her. She's the common ancestor. These are my first cousins. In the case of them, it's my grandparents. Those are my first cousins on my dad's side. Here's my first cousin on my mom's side. Here's my new aunt, Carol. I just did a whole podcast episode about finding my new Aunt Carol and figuring out that relationship. She's lovely. This down here is my dad's first cousin. If I go to the next page, you know, it just keeps going, right? So these are my mom's first cousins, and every one of them has a common ancestor hint because I have a tree attached to my DNA results and they have a tree attached to their DNA results. Now, cousin Celia here, she only has 5 people in her tree, probably herself and her parents and maybe one or two of her grandparents. That's it. But Ancestry was still able to figure out how we were related because I have more information in my tree and because other people might have information in their tree that helps to bridge that gap. So this common ancestor hint is just a hint. It is just a suggestion for how an algorithm looks at the family trees and thinks that you might be related. You do still have to review it. So I'm going to come down here to cousin Catherine. Catherine is a new cousin that I discovered when I found out the identity and whereabouts of my great-great-grandmother. And it tells me that Catherine could be my second cousin one time removed, and that Park and Carrie could be our common ancestors. Carrie, of course, is that great-great-grandmother that I found. That was episode 1 of my podcast. I think I told that whole story. Okay, and then it will show me a little relationship ladder for how I am possibly related to Catherine. Remember, thinking in ladders. Carrie and her husband Park, her ex-husband Park, they're common ancestors. Frederick and Robert are brothers. Fred and Carmel are first cousins. Steve and Catherine are second cousins. And then I am Catherine's second cousin, one time removed. Now, I happen to know that this is true. And part of the reason I know it's true is because all of these boxes are white. That means all of this information is already in my family tree. If any of these boxes are kind of translucent and have a dotted line around them, that means this information is coming from someone else's tree, and you need to be able to go and figure out, you can click on it and it will show you exactly what other trees or what other records are available, okay? So that is kind of the foundational exploration that I want you to do. So your homework assignment is 1. If you have not yet started a tree, go watch the Family Tree Building 101 video over on ancestry.com/education. Family Tree Building 101, start your family tree. If you already have a family tree started, you're going to go into your account settings and make sure that your DNA is linked to you in that tree, okay? And then, for those of you who already have a family tree started, your homework assignment is this. I want you to use that filter on your match list and start exploring those common ancestor hints. See if you can figure out, is the predicted relationship really what I think the relationship is? Do I already have this person or these ancestors in my family tree? Now remember, this was an AncestryDNA 101 basic class. In a few weeks, I'll be teaching another advanced, a little bit more advanced DNA matches class where we'll dive more deeply into the AncestryDNA match list, and we'll talk about what you can do with that match list as far as creating custom groups and starting to use that as evidence to either discover biological family members or add a layer of genetic evidence onto your family tree. Okay, now I see that there's still a ton of questions. Member Services has done a fantastic job and ProGen in the Q&A answering so many of your questions today, but let me just give you a couple of last links and I want you to get ready to write them down, okay? The first one is ancestry.com/education. That's where you're going to go to register for future virtual events just like this one. It's also where the recording of this event will be published within just a few days. It usually takes us 2 to 4 days to get that up, but you will then have access to come back and watch any or all of what we just walked through so that you can refresh your memory, immerse yourself in the language of the math and the science of DNA. It is totally possible, and I want to just tell you, it will open up a whole new world of family history exploration for you. DNA has completely changed the way that I approach my family tree. We have 3 minutes left, and I just want to end with a little bit of a story. And then I'll provide you with one more link. So my dad is who actually really got me into family history. I was 12 years old and he had me take a computer. He sent me to computer camp so I could learn how to use a computer. It was the 1980s. I was one of the only 2 girls there. But he had bought me a shiny new compact 64 computer for our home. And he took the family genealogy that was in a box and he set it on the desk next to me at this new computer that was loaded with the newest DOS-based version of the family history software. And he said, now that you know how to use this thing, I need you to take all this information and put it in there. And so that's what I spent a lot of my teenage years doing, was data entry of our family history based on family history research that my father had done or had inherited. And then I tackled my mom's family history that she and her uncle had been working on forever. And that just kind of was the new thing back in the 1980s into the early 1990s, was this computerized genealogy. And there were some people who were so overwhelmed by it. But just like they learned how to use a computer as new technology to do family history, now, starting in 2012 with AncestryDNA, we have this new technology that allows us to do family history faster and in a different way. My dad kind of drifted away from family history for a lot of years. He was raising a family, he was involved in his career, and as he was getting ready to retire about 8 or 9 years ago, he asked if he could start working on our family history together again. And so my dad and I set a date, and every Sunday night, and I think in eight and a half years now, we have only missed 4 times. He and I meet. I call him on FaceTime. We hop on a call no matter where we are in the world. He has his computer open. I have my computer open. I have my phone sitting on a little stand in between my 2 screens. We open up the family tree and we open up our DNA match list, and we spend from about 9:30 at night every Sunday night until about 2 in the morning working through our new DNA matches and trying to figure out how they're related. And the number of discoveries that we have made, the number of cousins that we have reconnected with, the photos and stories that we have found has just accelerated those discoveries that we're making. But for me, there's 2 things that are more important. One is the relationship that I've developed with my dad, who's now one of my best friends, and the layer of genetic evidence that I've been able to put on my tree to know that the research that I've been doing is accurate. And in some cases, I've found where the research I did was wrong. And so I've been able to correct my own mistakes because of the genetic evidence that I'm able to work into my family tree. So no matter where you are on your family history journey or where you are with your AncestryDNA level of knowledge, I just want you to know that DNA is an accelerator and that I hope you dive in and have fun with it. And if you have more questions, you can come to the Ancestry Facebook page. That Facebook page, just Ancestry. It's facebook.com/AncestryUS for those of you who are here in the US, Ancestry CA for those of you who are our Canadian friends, Ancestry UK for our UK friends. We have Facebook pages where you can send DMs for our member services team. You can also participate in Facebook Lives where I do live Q&A every other week. Or you can find me on social media. I'm lots of places. I'm most active on Instagram, and send me questions as well. So lots of ways for you to get help and get your questions answered, but I hope that you'll just come back to these virtual events. We hold them almost every week and continue to learn. Go back and watch the videos when the replays are available and continue to learn that way. Okay, well, we are out of time, so thank you all so much for being here today. I'm so glad you were able to join us for this live event. If you'll do me one favor before you go, in the chat, not the Q&A, in the chat, if you would just please leave a comment about one new thing you learned today. That's super helpful for 2 reasons. One, it helps me know if I'm pacing things correctly, if I'm teaching you what you need. And 2, the fact of actually typing out your answer means you're more likely to remember it. That's all I have for you today. Until next time, I'm Crista Cowan. Have fun.